This is a diagonal matrix. I have taken a diagonal matrix of order 5 by 5, that is 5 rows and 5 columns. And here you can see that most of the numbers are zeros and only the elements in a diagonal are non-zeros. So the important thing is, other than diagonal, all elements must be 0, then only we say it's a diagonal matrix. Suppose I have some element here, let us say 5, then it's not a diagonal matrix. This must be 0. So the important condition is all those elements must be 0. So let us see how we can define this one. See, if this is a matrix M, then M of ij is 0. If I is not equal to j, M of ij should be 0. If I is not equal to j, then it is a diagonal matrix. If they are equal, then the elements may be 0, non-zero. We don't bother about that. We bother about rest of the elements. All these elements must be 0 and these elements are 0. So these elements are non-zero elements, rest of the elements are zeros. So I have given a definition of diagonal matrix. Now, if I have to represent a diagonal matrix in a program, then for a matrix I have to take two-dimensional array, 5 rows and 5 columns. But if I take a two-dimensional array of size 5 by 5, most of the elements will be zeros. So I'll show it. So like this, if I take a two-dimensional array for storing this matrix, then most of the elements are zeros. If these are integers and integer is taking 2 bytes, then total how many bytes of memory this array is consuming? There are 5 into 5 elements are there, that is 25 elements are there, and each element is taking 2 bytes. Suppose for an integer, then it is taking 50 bytes. 50 bytes of memory it's consuming. So if I am storing this in 50 bytes of memory, then storage of 0 elements is unnecessary. So it is wasting space. As well as when I am processing on diagonal matrices, like if I am adding 2 diagonal matrices, then adding of zeros is of no use. If I am multiplying 2 diagonal matrices, then multiplication with zeros is of no use. So I will be wasting time in processing upon zeros. So the idea here is that we want to store only non-zero elements. So how we can store only non-zero elements? So for only non-zero elements, we can take just a single dimension array and store these elements. So let us see how we can do that. Now let us see how we can represent a diagonal matrix in just a single dimension array. So I will take a single dimension array, let us say A of size 5, because only I have 5 non-zero elements. So I have an array of size 5. This array starting index is 0, but here if you observe, I have taken the indices from 1 onwards. So in mathematics, we start indices from 1 onwards, so that's what I am following. So if you want, you can change the indices from 0 also. Then this array, that is in programming, it is in C programming or in C++ programming, the array starts from 0. So I have taken an array from 0. Now I want to store only non-zero elements. So let us store those elements. 3, 7, 4, 9 and 6. So I have stored only non-zero elements. Now let us see how we can access these elements from a single dimension array. If I want to access M of 1, 1, this element, then it is at 0. If I want to access M of 2, 2, this element 2, 2, it is at 1. So only diagonal elements are there. So if I want to access any element from matrix M of I, j, this I am calling it as M, but it is stored in an array. Then from where I can get the element? First of all, if I is equal to j, then only we have an element, right? So if I is equal to j, then 2, 2 is present at 1, 3, 3 is present at 2. So element is present at I minus 1. Or even I can say j minus 1. So this is very simple. Now we will see how we can write a C program code for representing this one. So I will write down just required code for implementing this diagonal matrix using C language. So for that, first of all, I need an array. A of what size? For my example, it is 5. If you want, you can also take a dynamic array of variable size, whichever size you want. At runtime, you can create a dynamic array. So I am not writing a complete program, just I am showing you the pieces of code. Now, for storing data in a matrix, that is this matrix, or retrieving the data in a matrix, that is actually in a 1D array, I need two functions, that is for setting the data and getting the data. So set and get functions I need. So let us write first set function for saving data or storing data in this one. So first of all, it needs array. First parameter is array. Which array? See, in my program, I may be having many matrices which are diagonal matrix. So whichever the diagonal matrix is, I can pass it as parameter. Then next, it needs which element. Suppose this element. Along with this, it also needs row number and column number, that is I and j. So three more parameters are required, that is I, j, and x is the element that I want to store. So these are the parameters of a function. First of all, an array in which you want to store what is the row number, what is the column number, and what is the element. Now, if I am giving any element for storing this one, then actually it should be stored in this array that is being passed as parameter to this one. So before storing, first of all, check whether I and j are equal or not. So store only if they are equal. So if I is equal to j, then only set function will store the element. Where it will store the element? In an array, it will store the element at I minus 1, that is assigned with x. That's all. If I is not equal to j, do nothing, no need to do anything. So close this one. See, this is the formula just now we have seen that how we can access the elements, that is I minus 1. So this is set function. Now I need a function for reading the data or retrieving the data from some row number and column number. So for that, I will write a function called get. And this also needs an array, and it needs indices I and j, that is row number and column number, and it has to return the element. So whatever the element we want to retrieve, it has to return the element, so the return type is integer. Now inside this, I have to retrieve an element. So whatever the I and j values are given, from there it has to retrieve an element. But first of all, it should check whether I and j are equal or not, because we have the elements only for I is equal to j, that is diagonal. So check if I is equal to j. So I will write in the same line, if it is equal, then the return a of I minus 1. So it is at the same place where I have stored it. Otherwise, if it is not equal, then definitely the element is 0. So return 0. These are get and set functions we can write down and call them from our main function or from anywhere in the program. But we also have to pass the array in which the diagonal matrix is stored. So while writing the program, I will be writing a complete program and show you.